Hi students. As you know, when an electrical engineer designs a power transmission system, he needs to consider the economic aspect also. When it comes to the economics of power transmission system, we need to consider two aspects. One is the economic size of conductor. The second is the economic choice of transmission voltage. In the last class, we studied how we can choose the economic size of a conductor. In this class, we will see the economic choice of transmission voltage. That is, how we can choose the economic transmission voltage. In the economics of power transmission, we have to consider both conductor size and the transmission voltage. In this class, we are going to study the economic choice of transmission voltage. The transmission voltage for which the cost of conductors, cost of insulators, transformers, switchgear and other terminal apparatus is minimum is called economical transmission voltage. The advantages of high transmission voltage are: it reduces the volume of conductor material required, it increases the transmission efficiency, then it decreases the percentage line drop. So obviously the high transmission voltage is having certain advantages. There are certain limitations for this high transmission voltage also. As you know, these transmission towers are earthed. At high transmission voltage, the insulation required between these conductors and the earthed tower will increase. Then the clearance required between this conductor and ground will also increase at high transmission voltages. Then the distance required between the conductors will also increase at high transmission voltage. So we need to have longer cross arms. These are the certain limitations of high transmission voltage. Now let's see how we can choose the economic transmission voltage. First of all, we need to choose a standard transmission voltage. Then we have to find out the cost of these equipments. The cost of transformer, cost of switchgear, cost of lightning arrestor, cost of insulation and support, and the cost of conductor. The cost of all these equipments together is called capital cost. It's the capital cost of transmission system. Now we need to plot a graph between the cost and operating voltage. In the y-axis we have the cost, and in the x-axis we have the operating voltage or the transmission voltage. Now we have chosen one particular transmission voltage and they calculated the capital cost corresponding to this particular voltage. Now we choose another transmission voltage. We choose a higher voltage. Now again you find out the capital cost for this increased transmission voltage. As you know, when the transmission voltage increases, the cost of conductor will reduce and the cost of all other equipments will increase. The cost of cost of transformer, cost of switchgear, cost of lightning arrestor, the cost of insulation and support, all these things will increase. So now we have calculated the capital cost corresponding to the second transmission voltage. Now suppose this is the second transmission voltage we have chosen. We find out the total cost corresponding to this voltage. Now we increase the voltage. We find out the capital cost corresponding to that voltage. Again you can increase the voltage. We find out the capital cost for that voltage. This is another increased voltage. This is the cost corresponding to the fifth voltage. Now you can join these points. Now from this graph you can see this is the minimum cost point. Suppose this is O, this is A, this is the point P, this is the point B. So from this graph, the operating voltage corresponding to the minimum cost is OA. So OA is the optimum voltage. But nowadays this method of calculating the optimum voltage is rarely used. But usually we use an empirical formula to calculate the optimum voltage. V equals 5.5 into square root of 0.62 L plus 3P divided by 150, where V is the line voltage in kV, L is the length of the line in kilometer, and P is the maximum power transmitted in kilowatts per phase. To convert this phase power into three-phase power, we are multiplying this with 3. So using this empirical formula, we can calculate the most economical transmission voltage.